Okay, we're going to go over the day 5 homework. It's on the purple sheet. So the first one is going to be y equals sine of 1/4 x. This is a change in frequency. Amplitude is still 1. So frequency is 1/4. Don't forget period is 2 pi divided by b. So we're going to put 1/4 in the denominator. And when we're multiplying, when we're dividing fractions, we'll keep the first one the same, change division to multiplication, flip the bottom fraction, and that's how I got 8 pi. With that 8 pi, I'm plotting it over here, cutting 8 pi in half to get 4 pi. Half of 4 pi is 2 pi, and then 6 pi will be between 4 pi and 8 pi. Amplitude is 1, so 1 is going to be maximum, -1 is the minimum, and we sketch our sine curve. Number 2, we have 3 sine 2x. We have a change in amplitude and a change in frequency. The amplitude says that we're going to be 3 units away from our midline. The frequency of 2 changes the period to be pi, so notice that now our sine curve is going to end at pi. Please label your x-axis. Half of pi is pi over 2, half of pi over 2 is pi over 4, and so on. So again, we have the same shape of the sine curve, 0, high, 0, low, 0. Number 3, y is equal to 1/2 of 4 sine x. Again, 1/2 is the amplitude, so notice that it is going to be a half of a unit away from the midline. The 4 sine x, it's 2 pi divided by 4, so that pi over 2 is going to be period, so we're going to plot that at the end of the x-axis, and again, cut up the x-axis into quarters, so then we can plot our 5 key points for our sine curve. On the back, we have y is equal to 3 sine x minus 2. The first thing you want to make sure you notice that it did go down 2, so we have a new midline at y is equal to -2. The amplitude of 3 measures it's 3 units above the midline and 3 units below the midline. So up 3 from -2 is +1. Down 3 from -2 is -5, which will give us the minimum. When we do the range, we do get the minimum and the maximum inside our square brackets. Frequency is 1, so period stays 2 pi, just like our parent function, and that's what we're going to graph on the x-axis. Number 5, y equals 2 sine 2x plus 1. A little bit of everything here. Shift of up 1 means we now have a midline at 1. Amplitude of 2, so remember this is the amplitude, and this 2 is the frequency. So amplitude of 2 is 2 away from 1, which gives us a maximum of 3. 2 away from 1 down at the bottom, that gives a minimum of -1, which is what we get with our range. Frequency is 2, so I do 2 pi divided by 2. Pi is period. Notice we then plot pi at the end of the x-axis, cut pi in half, which is pi over 2, and then keep cutting those up into quarters. On number 6, a little bit different. It says on the axis below, sketch at least one cycle of a sine curve with an amplitude of 2, so a is equal to 2, a midline at -3/2, so that's going to be our vertical shift down, so our d value is -3/2, and a period of 2 pi. So no change in frequency, b is going to stay 1. So notice we plotted our x-axis, we scaled it 2 pi, pi in the middle, and so on. Down -3/2, so down 1.5, so we'll have a midline at -1.5. Amplitude of 2, so we have 2 units above -1.5, and then 2 units below -1.5, which will give us -3.5. And notice when I found the range, that's exactly what I got for my highs and my lows. So to find the range, we start from a negative amplitude to positive amplitude, and then since this time it's a down, it's a shift down, it's a subtract, I'm subtracting 1.5 from both of those, and that's how I'm getting those two numbers. On the next page, we are matching our equations to the graphs. Number 1 is letter F, because we look at a couple of things. The amplitude is at 3. So we know it's going to be a 3 sine something. And what I want to make sure you understand is the frequency. I'm going to highlight the sine graphs. I have one sine graph here. I'm going to change my color. And I have another sine graph here. So I have 2 sine curves that are within 0 to 360. So that's why it's y equals 3 sine 2x. So again, we have 2 sine curves from 0 to to 2 pi. So frequency answers the question, how many curves do you see, how many cycles do you see between 0 and 2 pi? And in question number 1, we see 2 of them. In question number 2, there is only one sine curve right here from 0 to 2 pi, so frequency is 1. Amplitude is going to be 3, just like in number 1. So this time, while it's going to be y equals 3 sine, it is going to be 3 sine 1x because we only have one sine curve. In letter B, looks like our amplitude stayed at 1. But again, let's count how many sine curves we have between 0 and 2 pi. I have one sine curve there. I'm going to change the color. And I have another sine curve here. So again, I have a total of 2 sine curves. So my frequency is going to be a 2x. The other way that we can do that to find frequency, and I'll show you this, and we did this a little bit over on the classwork and the notes, it takes up to pi for one sine curve. So that means that period is equal to pi. So then I can set pi equal to 2 pi divided by b, cross multiply, I get pi times b is equal to 2 pi. When I'm solving for a b, divide both sides by pi, I get b is equal to 2. Notice that matches. So there are 2 ways to get frequency if you're looking visually at the graph and you have enough information. You can either count how many curves you see, and that's your frequency, or you can figure out how long it takes for only one curve and then set up this equation, cross multiply to solve for b. Number 4 is a little bit harder to see. And it is choice C. That's kind of interesting how that ended up. When we follow this curve, it actually is going to keep going, 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 and it's going to go off the screen. We see 1/4 of the sine curve. Well, how do you know for sure it's 1/4? Again, that's harder to see because we don't actually have a period from which we can work on. And that way we'll just kind of do it by eye, visually see that it's only 1/4 of the curve that's visible. Letter E, y equals, and we have an amplitude of 1.5, so 3/2 or 1.5. We do get letter E as the correct equation because we see 1/2 of the sine curve between 0 and 2 pi. Between negative 2 pi and 2 pi, we do actually see the entire sine curve. It is reflected, but it's because it's being stretched out. Number 6, the correct answer is choice D. We have 1/2 as the amplitude. And if you want to count along with me how many sine curves we see, I have 1, 2, and 3. I have 3 sine curves, so that means that my frequency is 3. It's a little bit harder to figure out the period. We've got a 2 pi over there and a pi over here, so it gets a little bit harder because we're talking about in thirds. And I would go by visually making sure that you can see that there are 3 sine curves that are there. That's why the equation for number 6 is going to be y is equal to 1/2 sine of 3x.